Welcome to today's 5-minute lesson. Today I'm going to be continuing with kinematics. I want to start by cleaning up something that I maybe forgot to address a little bit last time. So it's fairly typical when you're talking about the change in something to use the symbol delta, right? So that's a triangle. So that delta means change in. So for example, if I have delta x, that means the change in distance, which is change in x. I could also write delta v for change in velocity. You can write that other ways, and depending on your teacher and your book and whatever, you might have different conventions. So for example, delta x can also be written as the final position minus the initial position. Which would be, x minus x naught. The little o, the little circle means a naught. We would say that naught means starting. You can also say x final minus x initial. That's also fairly typical to see xf minus xi, etc. And the same thing for velocity. Vf minus vi or v minus v naught is the same as delta v. And that's very important because when we learn the kinematics equations, some of them treat the final and initial variables differently. In other ones, it's just the same. So for example, so there are three major kinematics equations that we use using the variables that I outlined last time. So we have delta x, which is change in position, which is the same as x minus x naught. Then there's velocity, but initial velocity and final velocity are actually two separate variables for reasons you'll see in just a bit. Then acceleration, which is, as you might recall, change in velocity over change in time, and then the last one is time itself. So we've got delta x, v, v naught, a, and t. There's your 5 variables that we use in the different kinematics equations. Now here's the trick with the 3 core kinematics equations that you use all the time. There are other ones, but they're mostly manipulations of these. Maybe I'll cover it. And how they're derived, I will talk about it maybe in another video because that's also interesting, but that's not the focus. I want to talk about how to use these equations. So the basic equation, I'll make a little space here. The basic kinematics equations you're going to see are, first one is delta x equals v naught times t plus 1/2 times a times t squared. All right, and that's the distance. That's the distance related one. We're relating distance, acceleration, time, and initial velocity. Then the next equation is v equals v naught plus a times t. And the third one you'll see is v squared equals v naught squared plus 2 times a times delta x. So those are your 3 kinematics equations. Notice something important about each of these kinematics equations. And here's the thing that usually people find challenging about physics, is they don't know which one they're supposed to use. When you're just told, oh, use this equation, okay, I can turn my brain off and do algebra. Hopefully, if you can't do algebra, you shouldn't be taking physics. Everyone should be able to do algebra. That's just plug and chuck, right? Plug and chuck. Very straightforward. But then when I give you all 3 and say, okay, these 3 equations, pick which one you're supposed to use. Which one to use, right? So the way you know which one to use, look carefully. Each of these kinematics equations has 4 different variables. The first one has delta x, v naught, a, and t. The second one has v, v naught, a, and t, with no delta x. The third one has v, v naught, a, delta x, no t. Right? And the first one doesn't have v final, or v. So recognize that if I have 4 variables, I need to plug in numbers for 3 of them, and then I can get the 4th one. Any one of those, right? So for example, if I'm given a problem and I have delta x, I have t, I have a, I've got delta x, I've got t, and I've got a. I could solve for v naught if I plug in the first equation, right? I can't really use, now I can't use the third equation because there's no place for time. And I can't use the second equation because the variables don't line up. So choosing which equation hinges on what are the 3 things I have and what's the 4th thing I'm looking for. That's the key to understanding how to use the kinematics equations. So in the next video, I'll demonstrate how to use those kinematics equations. So hopefully that's helpful, and I'll see you next time.